Okay.
Sir, sir, shall we start, sir?
Yeah, we can start with it.
Yeah. Rajeshri, madam.
Yes, ma'am.
You can start, madam.
Yeah,
Sir
yes,
is
ma'am.
there.
Yes, ma'am. Yeah, yes, ma'am. Good evening to one and all. I warmly welcome you to day 5 of our online faculty development program. We are delighted to have all participants join us today as we continue our journey of learning and exploration. Thank you for being with us, and we look forward to another insightful and enriching session. We are We are delighted to welcome Dr. Rajesh Doria, Associate Professor in the Department of Information Technology, NIT Raipur. He holds a PhD from IIIT Allahabad and is an, is an eminent researcher in artificial intelligence, robotics, cloud computing, quantum computing, and network security. With more than a decade of academic experience, numerous high impact publications, funded research projects, and multiple keynote talks across India and abroad, Dr. Rajesh Doria has made significant contributions to cutting edge technological advancement. Dr. Rajesh Doria is widely recognized for his impactful work in high performance computing and robotics and has delivered expert sessions at leading institutions including IITs, NITs, and international universities. He has supervised several PhD and MTech scholars, organized major international conferences, and continue to lead innovative projects in quantum technologies and smart agriculture. His deeply expertise and inspiring delivery make him a highly sought after speaking in advanced computing domains. We are honored to have such an accomplished expert with us today. Please join me in warmly welcoming Dr. Rajesh Doria to lead today's session. Welcome, sir.
Thank you, madam. Thank you so much for giving such a nice introduction of mine. So it's really a great honor and privilege for me to take a session on this ATAL FDP. So I believe it's going to be a very useful and informative session to all the participants. So with this, if you permit, can I start my presentation?
Yes, sir.
Yes, sir.
Okay. Can you see my slides?
Yes, yes,
Yes,
sir.
sir.
Okay, thank you. Thank you so much. Please let me know if any interruption is there in between. So in my first session of this ATAL FDP, I am going to talk about what exactly is AI and what are its advances in robotics. And in this particular session, these are going to be contents. So first we are going to see what exactly we mean by artificial intelligence. And then thereafter, we are also going to see various aspects of artificial intelligence. For example, what are the fields of AI? What are the basic elements of AI? Then thereafter, how the legends have described or defined AI. Then whenever we talk about AI, we cannot leave robotics behind. Even you will be amazed to know that the term robot has introduced even before introducing the word AI. So we are also going to see what a robot means and what are the advances in robotics and how they have been evolved over the period of time. Then I felt that whenever we talk about AI and robotics, and especially robotics, so there is a need to understand, or you can say, to feel that when we want to work on this direction, then we must have to have some platform so that we can start working. So keeping that in mind, I have kept few simulation tools as well in this slide. So Webots and ROS are going to be there. So if in case some of the participants want to start working in the field of robotics, then they can just have a feel of these simulation tools. And I'll also be describing that how exactly they can start working in the field of robotics. And apart from that, specifically talking about robot operating system, so a new version ROS2 have come into picture. So I'll also be describing the differences in between ROS1 or ROS with ROS2 and how one can install the ROS and can start working in ROS. So those are going to be the initial contents. And if the time permits, then we are also going to see that we are also going to see the framework which we have developed and the services which we have introduced. So these are the contents which are going to be covered in the session one. So to begin with, first let us try to understand what is artificial intelligence. Now I'm damn sure that all of us are very well aware that what exactly we mean by artificial intelligence. So, yeah,
नहीं मुझे ये चाहिए मुझे ये समझ देखो ये कितनी कठिन है
can you please mute? Yeah. So whenever we are talking about AI, that means we are talking about a system that think like human, right? And it also means that we are talking about a system that is going to act like human, and it also means that it is going to think rationally and act rationally. So this is what makes AI different, because in this particular category, given the scenario, given the condition, we are going to take the best possible outcome, or you can say the best possible decision. For example, if you are going to if you are going to a market to purchase some vegetable, and it is very much obvious that you may have some specific point or bazaar where you buy vegetables and all, right? And usually what we do, we buy certain things from a particular shopkeeper only. But it is very much possible that on a particular point, on a particular day, what happens that that shopkeeper is not having the fresh vegetables, or it may selling the vegetables on a higher price. And just beside that shopkeeper, one more shopkeeper is there, and that shopkeeper is selling the vegetable in low price, or let's say he or she is selling more fresh vegetables. Then we as a human, what we tend to do, we immediately take the decision, we analyze it, okay, that we are getting some better opportunity, or we can have some better outcome. So that's what we mean by thinking rationally, because at a particular point of time, what best we can do, that quality we possess as a human, right? So this is what we mean by rationality. So we are able to think rationally, and then we are also able to act rationally. So this is going to make a lot of difference whenever we are going to talk about AI. Then this is how the term AI has been defined by famous personalities. So the Alan Turing has defined AI as a science and engineering of making intelligent machines, especially intelligent computer programs. And on the other hand, the founding father of AI, Marvin Charles Minsky, has defined AI as a science of making machines do things that would require intelligence if done by a man, right? So more or less, both the persons are saying the same thing, but they have described this AI in their own way. Apart from that, in the last definition, and this particular definition was published in the US Defense Report. And according to that, AI is a computerized system that exhibit behavior that is commonly thought of as requiring intelligence. So in short, whenever we try to incorporate the intelligence which we human got, so the moment we try to incorporate all those intelligence to a machine, that means we are talking about giving the AI capabilities to a machine, right? Apart from that, this famous personality Marvin Lee Minsky have also got the Turing Award in 1969 for doing a remarkable work in the field of AI. Now, if we just go through the AI timeline, then it all started in 1950 during with a Turing test. And in this particular test, the thing was the machine was supposed to trick the human thinking, means a human, if a machine is capable of tricking the human, that human thinking that it is talking to a human rather than a machine. So if a machine is able to do that, that means it has passed the Turing test. So it happened in 1950. Hello, slides are moving. Am I audible?
Yes, sir.
Yeah. So in 1955, in a conference, the term AI has been born. So the John McCarthy in a conference has coined this particular term. And in 1961, a robot called as Unimet came into picture in the uh, industry line of GM. So this was the first instance when a robot was introduced in a industrial pipeline. And then thereafter, the era of chatbot has also started in 1964, where our first chatbot named as Eliza came into picture. So it was a pioneer chatbot which was developed by Joseph at MIT. And this particular robot was able to hold the variety of conversation with the human, and still we can access and we can chat with this robot. So we can just Google it, and then you can start interacting with this bot. Then thereafter, if you talk about the mobile robots, then the development has started taking solid shape in 1966 onwards. So a robot named as Shaky, which was the first electronic robot, and it was designed by Stanford. And this particular robot was able to navigate in an environment. It was able to manipulate the objects, means of course the basic manipulation capabilities this particular robot was holding. So uh, this is the time where the first mobile robot, first electronic mobile robot came into picture. Then after 1966, nothing much has happened till 1997, when the IBM has developed a program, an AI program rather, named as Deep Blue. So what this particular program did at that time, that it beat the current world champion of that time by 4.5 to 2.5, and sorry, 4.5 to 3.5, and that's where suddenly the boom of AI had picked up. So everyone started that how this particular program have done so remarkable job. So the people then again started working in the direction. And then thereafter, in 1998, another robot named as Kismet came into picture, which was developed by Cynthia Brazil of MIT. And this particular robot was able to imitate number of human emotions using its eyelids, eyebrows, jaws, lips, head, and it was able to produce the emotions such as happy, sad, angry, disgust, surprise, So these many emotions, this particular robot was able to imitate. Then thereafter, number of robots by number of companies have been developed, and one in such category is a robot developed by Sony in 1999, which was a paid robot. So special thing regarding this particular robot was that it has got a locomotion of, means it has got a four-leg locomotion, and it was having the perception capabilities, other vision capabilities. Then in 2002, another robot, another industrial robot has been introduced, and the name of that industrial robot was Roomba. And this was the first mass-produced autonomous vacuum cleaner robot. And till date, it holds that record. So that was also a very good example where the robot has made their presence in home to home. Then in 2011, another chatbot which was developed by Apple came into picture. And then in the same year, another chatbot named as Watson have been developed. And this particular chatbot or bot you can say has been developed by IBM, and it was named after the CEO of that time of IBM. And what is specific about this particular robot that it was able to win a quiz competition in US, and the name of that quiz competition was the Jeopardy. So it is something like the KBC of India. So, by having the reasoning and analytical capabilities, this particular robot was very smartly able to answer all the quizzes. So that was a very specific thing, and still this robot is there in service. So in the cancer hospital of New York, US, still this particular robot is giving its services. So in the same category, number of more chatbot came into picture, such as you can Alexa, Tay, and now the number is many, right? So this particular Alexa was developed by Amazon, and Tay was developed by Microsoft. Yes, and the another specific thing regarding this Tay bot is that after after its development, when it was introduced for use to the user, after 24 hours, it has to be stopped because people started posting inflammatory comments and post and all. So this particular chatbot was able to analyze those comments, and then this particular robot started posting uh, the abusive comments as well. So after its launch, uh, maybe around 24 to 48 hours, the Microsoft has to shut down its services. And then in another notable development in 27, Google has developed one program called as AlphaGo. And this particular AlphaGo program has beat the current world champion of that time, Keyze, in the complex board game of Go. And that is a very complex game because chess has got number of possibilities. Similarly, if we just talk about the complexity or the number of moves which we have got in this particular game, is that it got around 2 to the power 170 moves. So there are number of this is a vast number of positions or combinations one has to analyze. So this particular program was able to analyze those many number of combination, and it was able to beat the world champion of that time. And now nowadays we can see number of chat boards and all those things are coming. Even the news anchors we can witness who are delivering the news and all, right? So this is a bit of AI timeline, and with this we can see how the AI has evolved over the period of time. Now, if we just talk about what are the basic elements which are there in the AI, and or you can say what capabilities AI is holding. So generally, whenever we talk about AI capability, that means we are able to process vast amount of structured and unstructured data, right? So with AI capabilities, we are able to process big amount of data. Means we as a human, we possess or we can process, we can store a vast amount of data. Then it also provides us the capability to reason with the things. Then with this, we also get the ability to learn from the historical patterns, right? So we have the learning capabilities, then we have the problem solving capabilities, and all those capabilities we are putting whenever we are trying to give AI capability to a system, right? Means the system should be able to hold big amount of data, it should be able to reason, it should be able to learn, and it must have problem solving capabilities. So these are the basic AI capabilities which we have to embed in a system whenever we talk about any AI powered system. Now, these are the fields of AI. So as you can see, the fields ranges from machine vision, image recognition, robotics, expert system, speech, NLP, right? Machine learning, deep learning, predictive analysis, speech to text, text to speech. So all these are nothing but the fields of AI only. So as we have discussed earlier that if we are talking about robot or robotics, that means we are talking about AI only. If we are talking about NLP or let's say machine learning, deep learning or generative AI or any related thing, that means we are talking about AI only. Now, these are the basic elements of AI. So we have got the world and we perceive the world with the help of some set of sensors, right? So after getting the data with the help of sensors, we just try to select the features and then with the help of those features, we prepare the models and all, and then we make some predictions. And thereafter, we take some actions with the help of some actuators. So this is how the basic AI unit look like when we uh, talk about how it is going to interact with the world. These are some of the applications of AI. So the applications of AI ranges from finance, education, business, automobile, manufacturing, gaming, government, healthcare. So these are some of the applications of AI, and there are many more, of course. Now, apart from that, there are few things which we must have to understand, and in that list is that first, what we mean by narrow AI and general AI. So whenever we talk about uh, addressing a specific problem, that means we are talking about narrow AI. For example, if you are developing a chess game, that means you are going to handle a particular task only, right? So that is nothing but the example of narrow AI only. And when we have got some AI solutions which is able to do number of tasks, variety of tasks, that means we are talking about general AI. So as of now, uh, in most cases, we have developed narrow AI solutions and the developments are going on to develop general AI solution. So if we talk about ourselves, then we are the example of general AI, right? Because we do variety of tasks, right? That means we let's say we study, we cook, we walk, we run, right? We analyze. So, see whatever capabilities we have got variety of capabilities, not a single one, right? So that means we are nothing but the example of general AI, and now we are making our effort to make systems like us only, and those are being called as embodied AI. So we'll cover that one in the upcoming session. And this one also we are going to discuss in detail in the upcoming session. So I'm just leaving this one, what we mean by generative AI. So just to give you a brief, Gen AI is nothing but field of AI, which is capable of generating text, images, or other data using generative model, often in response to prompts which we make. So whatever prompts, or whatever commands, or whatever hints or data we provide, based upon those data, the things are being generated with this particular type. Okay, so what it does, it just try to learn the patterns and the structure of the input to train the data, and with this it generate the new data which has got the similar characteristics. These are some of the generative AI applications. So it is being used in arts, design, music, content creation, financial forecasting, customer behavior analysis, demand forecasting, healthcare, fraud detection, content creation, virtual worlds. So the application of generative AI are many. Then in AI, we must have to know that what exactly is a perception and a learning. And one obvious question, are both the same? So the obvious answer that both the terms are not same. So whenever we talk about any momentaneous gain or momentaneous exposure, that means we are talking about perception. And with the over the period of time, whatever knowledge we have got, that knowledge is being termed as learning. So both the terms are not same, rather they are very much different, right? Now this is how we can relate AI with machine learning and deep learning. So AI is a superset and machine learning is a subset of it, and the deep learning is further subset of machine learning. And this is how we classify machine learning into two categories: supervised learning and unsupervised learning. So these are very basic things. So I'm just going to skip through this. So basically, in supervised learning, the input data is going to be labeled, right? And whereas in unsupervised learning, the input data is remain unlabeled. So we use training data set whenever we talk about supervised, and we just use the input data set when we talk about unsupervised. So this is how we define supervised and unsupervised learning. So this is another way of looking into it, that the clustering is the example of unsupervised and classification regression are the example of supervised learning. Now the thing which we are going to see in more detail is the soft computing and hard computing. So whenever we are talking about the hard computing, that means we are talking about the conventional intelligence, and it also means that we are talking about an analytical model. So where we write the program, and those programs are going to have fixed set of instructions and fixed set of sequence. So in that sequence only all the instructions are going to be executed, right? So the outputs are going to be well defined. And in the case of, the inputs are going to be well defined. But whenever we talk about soft computing, so it is going to present this attitude that the human mind has got. Means we have got the capability where we can store and process the information, which is imprecise and lacks uncertainty. So lacks certainty. So to give you better clarity, whenever there is a noise or whenever there is incompleteness in the data, that means we can think of soft computing solutions. So why? Because it presents capability to deal with the imprecision, uncertainty, or you can say the partial truth or the approximate data. And how do we do that? So there are number of soft computing methods, for example, fuzzy logic, neural network, probabilistic reasoning, and with time, they can evolve their programs and they present multi-valued logic. And with the help of that, what happens? They are able to handle non-linear data, or in other terms, you can say ambiguous and noisy data. And another advantage which we get with the soft computing technique is that we can have parallel computation. And with this, we can present the approximate answers rather than giving the precise answers. So this is how we can differentiate the hard computing with soft computing. Okay, whereas whereas hard computing works on two values logic and it works on exact input data, where in soft computing, if the data is noisy or ambiguous or incomplete, even in that condition, we can uh, utilize or we can apply this soft computing technique to get the work done. Now, let me see whether you guys are with me or not. So just to have a knowledge check, one question is there in the slide, and the question is, AI leads us to create a system who can think and behave like us. So can you tell me, is this statement true or false? Participants?
Yes, sir. Yes, sir. Visible, sir. Your screen is visible, sir.
I am asking a question that this particular thing is true or false. Can you answer me? It's a question, and the participants are supposed to answer it. AI leads us to create a system who can think and behave like us. So this statement is true or false?
True, sir.
True. Anyone else? Okay. So this particular statement is true, right? Very well done. Now, there is one more question. Which one of the following is the field of AI? Robotics?
All of the above.
All of the above?
Yes.
Okay, let's see. Yes. So all of the above are the field of AI, which we have seen while discussing the things in AI, that if you're talking about robotics, uh, computer vision, or text to speech or NLP, all those things. So that means we are talking about AI only. So all of these are going to be the field of AI only. Now, let us come to the next section where we are going to talk about what we mean by a robot. So the term robot was first used in 1920 in a play called RUR, Ruslem's Universal Robot, by the Czech writer called Capek. And then thereafter, this particular word was used to call the forced labor. So robota was the word which was used by the Czech writer at that time. So this is how this particular term robot came into picture. Now, whenever we are talking about a robot, most of the cases we are going to talk about a robot which is going to act as a standalone entity. And that particular robot is going to specifically designed to accomplish some specific tasks, right? So each and every robot is going to have its own set of tasks, right? So each and every robot is not going to do all the kind of tasks, obviously. And it has also been felt that with time, the robot also need to adopt with new functionalities. And the cost of a robot is also going to be proportional to the functionality of a robot. So the moment you try to incorporate or have more functionalities, more features into a robot, of course, the cost of the robot is going to be increased. And now, if we just try to define how we can define a robot or how I define a robot, so a robot is nothing but a cyber physical machine, a cyber physical universal reprogrammable machine that can exhibit intelligence and can work autonomously when required. So if all these keywords are there, then almost you can define each and every type of robot with it. So this is how we can do it. So in this diagram, we can say number of industrial robots are there, mobile robots are there, Roomba robot is there, PR2 robot is also there, Now robot, Hope2 robot, and this And along with this, if we just try to trace the development of robots or robotics, then we can see that it all started even before the AI, right? And then it has reported its development along with the path of AI only. So it's very much similar, you can say, the development which has been reported in the field of robotics, right? So as we have understood that whenever we are talking about robotics, that means we are talking about AI only. Now, if we just talk about the classification of robots, then the robots can be classified into two categories. The first one is mobile robot and the other one is fixed robot. So it's based upon the environment. Okay. So when we are talking about mobile robots, so the mobile robots can be aquatic, terrestrial, and airborne. And in terrestrial robots, again, it can be classified into two categories, wheeled and legged. And then if we just try to classify the robot based upon their application, so it can be classified as an industrial robot or the service robot. So in industry, it can be logistic robot, manufacturing. In service, it can be for home, medical, education, defense. So there can be variety of classification of robotics. So I have just presented two of them. Now, as discussed, these are number of applications, or these are few of the applications of robotics rather: industrial, agriculture, underwater, space, military, entertainment, security and surveillance, healthcare. So these are some of the applications of robotics. Now, if we just try to analyze what has been the impact of robots in our day-to-day work, and especially in the industry. So in the first diagram, you can see that in 1995, per thousand workers, there were only 0.49 robot, and it has been increased significantly to 1.04 robots in 2005, and it kept increasing thereafter. So as you can see, in 2017, that number has come to 1.79. So day by day, year by year, the number of robots are increasing, or you can say they are taking the place of the worker. And the same trend you can find in this particular second graph, where the routine manual job percentage was around 27%, right, in 1983. And it has been reduced up to 20% in 2016 as per the US employment report. So the routine manual job, which include production, maintenance, and transportation jobs, they have increased with time. Okay. So we can say the robots are not coming, rather they have already arrived, and they have very well taken, or they have started taking the significant place of humans in the industry. Now, if we just talk about the countries having the highest density of robot workers, so in this graph, we can see the South Korea has got the highest density of robot workers. So out of 10,000 employees, the South Korea is having around 855 robots. Japan is the next in that category, having 364 robots per 10,000 employees, and following by Germany, Sweden, US, Italy. So that has been the trend in this country. Now, one more other studies there, interesting studies there. So how advanced robotics will impact job market. So when this particular survey was done on number of companies in number of countries. So as you can see in this particular plot, that in China, around 67% companies think that the robotics are going to impact the job market. So 5 to 10% company with this much companies are saying, or some companies, this is the share where they are saying that around 20% job market will be impacted. And this is here where they are saying that more than 20% job market will be impacting. So in total, you can say that is 67% companies are thinking that they are going to get impacted by the introduction of robotics in the industry, right? So here is the India where the 41% industry personnel think that the with the rise of robotics, the job market is going to get affected, right? So by how much percent? So this is the percentage. So we can see around 10 and 11 to 20% have got the equal share more or less. Now, there are few things whenever any development is being done in the field of robotics. So a robot must have to follow these three laws, which is a robot may not injure a human being, the first one. And the second one, a robot must obey orders. And the third one, a robot must protect its own existence when the first two are being followed. So whenever a robot is being developed, so these are the three laws of robotics which must have to be followed, right? And these are the 4D environments in which in most of the cases the robots are being used, which is the robots are mostly being used in a dull environment, dangerous environment, dirty, dear. Dull means where some repeated task is being done. So with time it becomes dull, right? Dangerous, for example, in some nuclear facility, one has to do and operate certain things or do some jobs. So those things are going to be called as dangerous jobs. Dirty, for example, sewerage cleaning and other things. So those are going to be classified as dirty, dear, where some sort of money is going to be made. So these are the broad classification of application or a broad classification of the environments in which the robots are being used in general. And these are the 4S tasks which are being done by the robots, that is assistance, autonomous, automation, augmentation. So with robot assistants are being provided, then they are being used for the autonomous purposes, for example in space and all. Then automation is being done as we have seen in the uh, industrial cases, right? Augmentation, for example, where the limb replacement is being done. So those are nothing but the examples of augmentations where along with the robots, the people are doing their work. Now, if we just discuss few advances in the field of robotics, so few of them I am going to cover. For example, we are going to discuss what developments have been done by the Boston Dynamics, which is one of the pioneer company which is doing a fantastic job in the field of robotics. Then what developments is being reported in the field of nano robots. Then what we mean by soft robots, Mr. Robot, service robots, cloud robotics. So to start with, first we are going to see the developments which are being done by the Boston Dynamics, which is a company, a spin-off company from the MIT, which has been founded in 1992. So it has developed a series of remarkable robots, for example, Big Dog, also called as LS3, then Spot, Atlas, Handle, and since 2019, Spot has also been made commercially available. So a very fantastic job is being done, and now even we can see those you know dog shaped robots even in IPL or in cricket matches. So all those things were being was developed by Boston Dynamics only. So let me show you one video which will give you an idea what developments are being done in Boston Dynamics. Please let me know if the audio, if you can hear the audio or you can see the video. Can you please confirm audio video is available? Participants?
Sir, audio I could not hear, sir. Video is good, sir.
Oh.
Now better, sir. Now it's better.
See, the way this particular uh, bipedal robot is working, so it involves a lot of complexity. It's not very simple as that. How this poor robot is going to maintain balance. This particular that is coverage physically. How beautifully the robot was still able to find its object. Even after falling, this robot is going to recover. So this is one development, and then the other one is the nanobots. So these are very tiny robots, and these are going to swim in a bloodstream, and then they are going to do the designated job. So they can have micro camera, they can have a payload. So with the help of this payload, means we can deliver a drug on a specific part in a particular controlled quantity. So wherever it has to be applied, specifically we can apply over there. So it can swim in our bloodstream, and there are many things which can be done. And there are a variety of ways through which we can power it. So it can be with internal power sources, it can be with the external power sources. So now I guess I should play a video so that it is going to give you a better idea how the nanorobots are going to be used in future.
Cancer rates have been steadily increasing, making it the leading cause of death in the Western world. Cancer treatment is costly both to individuals and to healthcare funds. Surprisingly, despite scientific and medical advances, more than 30% of cancer patients receive the wrong drug. Drugs that are ineffective in fighting cancer weaken the patient and may not bring the best results. However, this can change. Chemical engineering professor Avi Schroeder and his team at Technion Israel Institute of Technology developed a unique nanotechnology method to explore the efficiency of different drugs before treatment begins. To test a person's response to medication, drugs need to be tested within the patient's body inside the tumor, turning it into a small and safe treatment lab. Schroeder creates nanoparticles, each marked by a unique barcode that carries a specific medication. These nanoparticles are then injected into the blood and enter the malignant tissue, penetrating through microfissures that do not exist in healthy tissue. The nanoparticles then discharge the drug within the tumor cells. Following that, doctors take a biopsy of the tumor and can see by analyzing the barcodes which drug is most effective for treating the patient. This new development allows the drug diagnostic stage to take place within the patient's own body. This leads to clinical recommendations based on the patient's own response, being personalized medicine at its best. Such speedy answers will lead to a dramatic improvement in treating these prevalent cancers, saving countless lives, one nanoparticle at a time.
Now, with the help of this video, you can very well visualize that how it is going to revolutionize the medical field, right? And thereafter, another field is becoming very popular called as soft robotics, where in place of rigid bodies, robots, we are going to have the limbs with soft tissues, which is going to look like soft tissues. So with this, what is going to be there, that we will be able to work, will be working in close with the humans. So with this soft robotics, a lot of things are going to get changed. So let me show you video so that you can get an idea what we are going to have with the help of this soft robotics. So the soft tentacles are going to be developed, and then they are going to play a huge role in the upcoming development. So when the developments in the field of soft robotics are remarkable, then we are not going to see or perceive the robotic arms the way we perceive, nowadays, right? So all those hard links and all those things are going to be, gone. Now, another interesting field where a lot of advancements have been done, which is service robot. So let me directly show you video. So of course, with the help of this video, a robot is going to do a variety of jobs at your home. For example, they are going to mop the floor. They are going to if they are going to watering the plants and all, they are going to serve you tea, coffee, or whatever. Let's say if you want them to play a song for you or whatever it is. Okay, so a number of things can be done by a service robot at variety of places. So let me see. No, I don't have. Yes. So what happened when I went to Japan? So I went to a number of shops. So whenever I went to a shop, number of robots were greeting me. So I did not go to a shopkeeper to ask about any particular thing, that what is the specification of this product or this item, then so what is the cost, and what is specific about this thing. And even let's say in a shop, if only a single shopkeeper is there and multiple customers are there, then the shopkeeper won't be able to pay the attention to all the customers, right? So what happened that we tend to just move away from the shop because the shopkeeper is engaged with some other customer and we are not uh, able to find what we want to have from that shop, right? So to engage customer, this sort of robots are there and they are doing a great job. So let me show you one such experience. So in the shop, I'm just going, and then wherever I'm going, you can see these robots are following me. And they are trying to interact with me at the same time. So not even not for a single moment, I have the impression that I'm not being accompanied. And this is another one where it is bringing all the customers. And with this, push through the shop floor is going to know what the customer is the shop. And we're going to introduce something of the shop about. This very much like the announcement which we made in the shop. And it was a video taken 8 years back. Now what happened? I'm going to try to have an interaction with this robot. Just try to see the emotion and the gesture this particular robot is showcasing. Although this robot was only understanding Japanese language, so I tried my level best to interact with this robot in English. So just try to just try to observe the emotions and other gesture which is being shown by this robot. It's very interactive.
You are looking at me. You are looking at me. How do you do? How do you do? Are you good? You don't know English? You do not know English? You know English? No? Oh. Okay, fine, then I'll go. Oh, you must have to speak in English. You have to understand English. Otherwise, how I can, speak to you? I'm not. No, I cannot understand you. I'm not getting you. Oh. It's getting quite awkward. How? Then let it go. Arigato. 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 You understand that? Arigato? Arigato.
So these are very interactive robots, and it is going to improve a lot of business to the shopkeepers. So these sort of service robots are nowadays becoming very popular. Now, one more in that category is that Mr. Robot, and in short, we call it as the MD. And we have felt a strong need of this sort of robot in the Corona period. So let me play a video so that you can understand that what developments are being done in this direction as well.
There are various types of robots which can operate in a hospital. For the patient, it is like talking to a doctor face to face. I'm Rajiv Karwal. I'm chairman of Milagro Robots.
Can I also introduce myself?
Of course, Elf.
Hello, I am Milagro Roboti LF. Nice to meet you and hope we can be friends.
This great big story was made possible by Accenture.
I was always fascinated by robots, and I always felt that the next revolution amongst products would be in the robotic field. Our first robot came out in 2011, which was floor cleaning robots. Then we have kept on adding many new categories of robots. The focus on the healthcare industry started when the coronavirus was spreading havoc around the globe. I was seeing a situation in Italy where almost 30% of the healthcare workers were getting affected. At that point in time, we thought we also have humanoids and they are probably acting as reception robots or concierge robots. But they can easily serve as a telepresence for the doctors. We got a call from India's largest medical hospital and they said, can we do something together? And we took our robots, took their feedback, and they selected 2 robots for their use. One was the humanoid elf, which doubled for a doctor inside the ward, and also the floor cleaning robot, which killed the virus spores on the floor. See, initial response of the patients when they see a humanoid robot instead of the doctor is curiosity and maybe a little bit of doubt whether they would be satisfied.
And if there's anything, if you need any help or any questions, I'll be around, and see you soon.
Okay, thank you.
The patient gets accustomed to it very, very quickly, and it's almost like face-to-face talking with a doctor. And also it is safe for the doctor. It is also safe for the patient.
Would you like me to dance?
It has a lot of capabilities in terms of dancing, singing, showing movies, etc. So in that way, the patient remains connected, is in a good mood, and the robot keeps on wandering around the ward.
I am your robo doctor. Take care. You will be well soon.
Thank you.
In India, this pandemic has been the turning point for the services robots industry. It really makes me happy when I see that our robots are helping people lead better lives, stay safe, stay healthy, and share that happiness with us. I don't have a favorite amongst my robots. They are all like my children, so it's very difficult.
Am I not your favorite?
Of course you are, of course.
I love you.
Me too, but right now is not the time.
Would you like me to dance?
I guess now you would have realized, and we have very strongly felt the need of this sort of solution or the service robots in that corona pandemic, right? So thereafter, another major development which is being done in the field of robotics or being reported in the field of robotics is the cloud robotics. So I would like to play this particular clip. This is a movie clip of Matrix movie. So I would like to ask from all the participants just to watch this clip closely and let me know that what exactly has been done in this clip. Okay, so I request all the participants to please pay their attention and let me know what has just happened in this clip.
Can you fly that thing?
Not yet.
Operator.
Tank, I need a pilot program for a B-212 helicopter. Hurry. Let's go.
So can any participant just tell me what exactly just has happened in this clip? Any participant?
Excuse me, sir. Can you repeat?
Please repeat the question.
Okay, fine. A lot of noise is coming from the background. So as you can see that he was initially not having the capability of flying that helicopter. So he has just requested an operator at another place that I need to have that helicopter program. So then she requested, although she was not knowing initially how to fly that thing, which is helicopter. So after getting the helicopter program, then she was able to fly it. So on the run, we can have the capabilities initially which we were not having. So this is what we mean by cloud robotics. So our robot initially may be designed for some specific functionalities or some things, right? But if the mandatory hardware or hardware data is available, then the capabilities can be provided to that robot on the fly, and that particular field is being called as cloud robotics. So when we talk about cloud robotics, so the things are being turned as a standalone robot, network robot, and cloud robots. So a single standalone robot can function autonomously, and a group of robot can form a network, right? And then they can work in a group. And in case of cloud robotics, a robot is going to take, or you can say, can offload some of its tasks to the cloud. Let's say a robot has just taken a image, has just taken an image of an object, and that robot does not know how to operate that object. So it has just passed that image to the cloud, and then the cloud has provided all the semantics and the instruction how to deal with that object. So this is what the things are being done. And apart from that, one more scenario one can consider, let's say, uh, a map has to be created and it is going to take a lot of computational power, and a robot does not possess onboard computation power, means that it is not possessing that much onboard computational power. So all that computation can be offloaded to the cloud, and in the cloud all those computations are going to be done, and the final result is going to send back to the robot, and then the robot can take the decision accordingly. So these are some of the functionalities or things that can be there with the evolution of cloud robotics. So with this, a single robot can learn about the environment, and then that learning can be shared with the other robots as well. So a lot of work is being done in this area as well. And then for that to have, one must understand what is a service. Only then one can think of providing robot as a service, or we can say a services to the robots. So a service is nothing but a logical encapsulation of self-contained functionality where we can change, modify, or remove the services without affecting the other services. So this is what, or this is how we define a service. And with the help of this, then we can define a cloud computing paradigm. And the moment we are familiar with cloud computing, the provision which we can get with the cloud computing, the resources which one can have from the cloud computing, then all those resources can be made available to the robot. Okay, so in general, cloud computing is nothing but a model where you are going to get access with the variety of devices. On-demand access can be there, and variety of computing resources can be configured, right? And it can be made available with minimal management effort to the end user, and it can be a robot. So this is what we get with the cloud computing. So just to make you aware that what happens in cloud robotics, right? So to have, one must understand what is a robot, then what is the cloud computing, then only we can get accustomed to the cloud robotics. So this was all about the advancement. So as I told you that we are also going to discuss how we can start working in the field of robotics. For that to have some simulation tools are going to be discussed. And the first in that category is the robot operating system. So first we are going to see some foundational things. For example, what is a ROS? So just to begin with, the ROS is nothing but it's an open source meta operating system for a robot, and it is going to provide number of things. For example, it is going to provide you hardware abstraction, low-level device control, implementation of commonly used functionality, message passing, framework, package management functionality. So it is also going to provide you a number of tools and libraries which are generally being used to build, write the codes across multiple platforms. So it basically how usually it does that? It does that with the help of publisher subscriber model, which helps to communicate messages. So this is the just very basic introduction of ROS. It is something like operating system of a typical computer. So similarly, we have got a system for robots as well, which is going to provide you the hardware abstraction level. So just to give the introduction of ROS in some points, that is, it is going to be a sort of meta operating system for a robot. It is free and open source, the most important thing. And then it can be programmed in the variety of languages, for example, C, C++, Python. Then a packaging system is there, modularity approach it follows, and then the code reusability is there. For example, if you have got a navigation program, so that navigation program can be used in the variety of robots. No need to write the same navigation program again and again. And of course, the basic hardware capabilities or basic hardware architecture of those robots has to be similar. Then the device abstraction is also going to be there. So you just write a code once, and then that code can be used across multiple platforms. Then if we talk about the core components, so nodes, topics, services, parameters, rows, masters are there. So nodes are nothing but the fundamental process in robot operating system. The way we have got a process in a typical operating system, similarly in robot operating system, we have got nodes. And all those nodes interact with each other with the help of topics. And they do it with the help of publish, subscribe model, or you can say publisher subscriber model. Okay, and with the help of messages, a particular data structure can be passed over a particular topic. So we will get to know about all these things in detail. So as discussed, a node is nothing but a process that use robot operating system framework, and the nodes may lie in different machines, and they get to know about each other. For example, this node can interact with this node with the help of a central unit called as ROS code. Okay, so in this particular animation, you can see that we have got three nodes. This is first node, this is second node, and third node, right? And these nodes are communicating with each other with some messages, right, over some topics. So it is very much possible that a node is generating variety of data, and there can be various types of those data, right? So it is very much possible that on a particular type of data, another node is interested in. So that particular type is being defined as a topic. So in whatever topic a particular node is interested in, it is going to subscribe upon it only. So this is how thing happens in the background. So a publisher can publish a variety of data on variety of topics, and the nodes means the interesting nodes can subscribe upon that topic. So this is how they get the data. So as you can see over here, a node is publishing over a particular topic, and in this particular topic, two nodes were interested in. So when the data has been published, these two nodes are going to get this data. Right? So this is how it works. Over here you can see one more node has started publishing the data on that topic, and then the other nodes who have subscribed to that topic has got that data. And this is how our service look like. So whenever a service request has been made, a node is going to get a response for it. So this is how our service is being defined in the ROS framework. And these are some of the robots which are there or which are being supported by robot operating system. Now robot means you can see the number of humanoid robots, number of mobile robots, industrial robots, even the drones are there, right? So the most important thing is I told you it is free and open source and one can start working in it. So let me see whether videos, yes, one video is available. So you will get an idea about the capabilities which ROS offers. Let me take this one. So now I guess you would have got the idea that the capabilities ROS offers, right? Now, apart from that, if you just try to work on ROS, then now you are going to get the opportunity to work upon ROS 2. So this is the recent development which they have introduced, and in this particular development, they have embedded this particular capability, which is data distribution service with that. So with the introduction of this data distribution services, the additional things which we are going to get in ROS is the automatic discovery of the essential services or the functionalities which are going to be there. Then it is also going to ensure the quality of services. For example, it must be reliable, right? It must be reliable, secured, and there are many more which are going to be showcased in the upcoming slides. And apart from that, it is also going to provide you better performance. So these are the functionalities which the ROS 2 is going to provide. For example, true cross platform support, so you can run ROS, let's say on Linux, Windows, Mac, Windows, and then you are also going to provide the security, various security aspect in the form of authentication, authorization, encryption, and then you can also think of using it in on the real-time applications. Then the variety of tools that you are also going to get with this. And this is the basic architecture of ROS 1 and ROS 2. As you can see, over here TCP and UDP protocols were being used, and over here this particular additional layer has been created, and intra-process APIs have been added over here. So this is how ROS 2 work if you talk about the architecture of ROS 1 and ROS 2. So as discussed, it is going to have decentralized discovery. That means there is no need of having ROS master. It is going to have peer-to-peer model or peer-to-peer architecture. Then automatic matching is going to be there, and it is going to have publish subscriber data flow where the topics and topics are going to be there in the form of data writers and data readers. So if you are just publishing some data, then it is going to be termed in the form of data writer. And if you are getting the data, then you are going to be treated as the data reader. Then these are some of the quality of services which are going to be ensured whenever we are going to work in ROS tool. And those quality of service parameters are reliability, best effort, durability, history. So all those additional things we are going to get with the introduction of this DDS function. And this is how the overall architecture of ROS2 looks like. As you can see, number of participants are there, and they are publishing the data and they are subscribing the data over certain topics. But the only difference over here is that now all the things are being seen in the terms of data writer and data reader. So we have discussed all those things, that what additional features we are going to get with ROS2. So as discussed, they are going to be, they can be used over a variety of platforms, and in real-time environment they can be used, right? And they are going to offer you better performance. So these are some of the benefits, and that are that there is going to be no single point of failure, since it is going to a peer-to-peer model. So if in case some node is not working, so other node is going to get into picture to get the work done. So all the quality of service parameters you can configure, you can define as per the application. It is also going to offer security mechanism. It is going to offer better scalability, and cross-platform support is going to be provided so that real-time applications can be created or built. These are some of the distributions of ROS, and as I told you that this is where you can start it. So you can just log in on this web page, and then you are going to land up over here. Then you can click on getting started, and then thereafter number of versions are going to be there. So you can pick any one of them, you can install it, and a list of commands are going to be there. So you can just follow those commands, and then you can install it. And after installation, you can find these tutorials. And in these tutorials, there are three types of tutorials: one for the beginner, another one for the intermediate, and then for the expert, or you can say developers. So this is what you are going to get in the beginner level. So you are going to know how to install, how to configure your environment, how to create a node, how to create a workspace, how to create a topic, and how to get things done. Okay, how to operate on variety of tools and libraries. So all those things you can learn with the help of these tutorials. And these, since the support of ROS1 has been stopped, now all the development is being done in ROS2, and I have already told you the advantage one is going to get with ROS2. So this is the current version or distribution, and it is going to have its end of life, means you are going to get support till December 2026. So these are all the ROS2 distributions. And if in case you try to work around ROS2, then this is the URL which you can just log in. And these are those tutorials which you can follow after the installation. So a variety of options are available to install it. So it's up to you which one you choose. And then after it, you can just install it, and you can just go through these tutorials. Thereafter, I would also like to tell you about the next tool, which is Webbots. It is also a very good tool, and the people who are very much familiar to Windows, it is going to be a good one for them. So what is a webboard? A webboard is again a mobile robot solution software. So the moment you want to work in the robotics field, first you need to learn what is a robot. Then again you will feel that there is a need to have an environment, there is a need to buy a real robot, and those are very costly affairs, right? So if in case you do not have but you want to work, then you can work around this simulation software. You can have ready-made robots. You can work around your algorithms, your approaches, and you can test it. Okay. And when that is done, then you can actually burn that program into the real robot. So it is also very much popular in the robotics community. So with this, what people can do, people can just model their world, their robots, then they can program it and they can simulate it. If each and everything goes fine, then they can transfer that code into the robot. So this is the prototyping cycle, basic prototyping cycle. To talk about the applications of robots, these are being used in the variety of applications, including multi-agent research, adaptive behavior research, mobile robotics teaching, and these are some of the snippets of that software. So you can see a variety of robots, are industrial robots, that Hawk2 robot, this Epoch robot, right? Even the Lunar robot and that pet robot. So let me play a video so that you can get an idea of the capabilities which robots offer. The only thing or only limitation that initially you can work around it is now it has become an open source, so you can install it, you can work it, but in order to get the support, you need to pay for it. So this is what is going to be there with webbots. Let me play this video. So now I guess you would have got the idea about the capability of webbots. Now these are the universities which are utilizing or which are using the webbots. You can see Stanford University is there, MIT is there, EPFL, Boston, CMU. A lot of universities, people from a lot of universities are making the use of this one to get their work done. So we have also done certain amount of work in this direction. So we have developed a framework where we have made number of robotic services, and then we have made available all those services to robots for which initially that robot was not designed for. So one such service in that category is the navigation, where the robot was having some difficulty in navigation. So the robot just send the data and it is getting the direction from the cloud where to move and how to move. So this is one service which we have developed, and thereafter one more service which we have developed, and that is how to create a map, and that is very computational intensive affair. So what exactly has been done, that the data has been taken, means the image data of course has been taken on a real time, and then that data has been sent to the cloud, uploaded to the cloud, and thereafter a map is being created. And then that map is being utilized for further future navigation. So that is the thing which has been done, and as told you that these are the benefits of cloud robotics, right? Then these are some of the maps which has been generated or created at the cloud. So with these things, we are already exiting the first session time. So I'll be ready to receive any doubt, any question for this session, if any.
Dear faculties, any queries? So, okay. Dear faculty members, kindly take a short break at this time. We request you to be back and ready to resume the session promptly after 15 minutes. Thank you, sir.
Aliet నిజంగా నిజంగా పిచ్చి నీకు నీకున్నంత ప్రపంచంలో ఎవ్వరు లేదు అన్నం ఎగ్గిపో మా ఫ్రెండ్స్
Okay, dear faculty members. Welcome back, dear faculty members. We hope you had a refreshing break. Let us now continue with the session. Welcome you, sir. Thank you.
I hope I am audible. Am I audible?
Yes, sir, you are.
Okay.
Yes, sir.
Yeah, I hope my slides are visible to you all.
Yes, sir.
Yes, sir.
Okay, thank you for confirmation. So, welcome to the second session. So in the second session, we are going to talk about the generative AI and what role it is playing in the field of robotics. And of course, whenever we are talking about generative AI and its role in robotics, so it is going to be the advanced robotics. Now, in this particular session, we are going to first discuss what is generative AI, the basic concept of generative AI, then the fundamentals of generative AI, then thereafter what are the roles of generative AI in robotics, and certain applications we are going to see, then certain case studies also we are going to see in this one. So to begin with, first let us try to understand what exactly we mean by Gen AI or generative artificial intelligence. So as discussed in the previous session, that Gen AI is nothing but it's a subfield or field of AI that creates new content like text, images, audio, and video by learning from large data sets. So a huge data set is going to be there of data, and from that data, it is going to create new content, and that content can be in the form of text, images, audio, and video. And how exactly it does that? Basically, it uses generative models to produce content in response to the prompts, such as writing a poem, generating a picture, or composing a music, or creating a video. So it can be anything. So I am damn sure that all of you are exposed to this Gen AI or Chat GPT and all. So already some pre-built generative models are there. So you might have heard about Chat GPT 5, 5.1 Pro, 3, right? So these are various models which are being used, and now it's up to you that what sort of data we are providing to these models and what expectations we have got. So it all depends upon how exactly you are crafting your prompts. Okay. Now, if we talk about the examples of Gen AI application, then with the help of it, you can have text generation where you can create emails, stories, and code. Then you can also have image generation. So with the help of it, you can create unique images from text description. Earlier, you would have witnessed that Ghibli images and all those things. So in the background, the concept was coming from the generative AI only. Only few characteristics were being taken from that Ghibli artist, you can say. Then audio and video creation can also be there. So with the help of this, one can produce music, sound effects, video contents, can edit contents. So it is also very much possible. Then you can have summarization, text summarization, and question answering. For example, let's say you have got a report of 100 page, and then you do not have the time to just read out that 100-page report. Rather, you just wanted to have a nutshell summary. So you can condense that amount of data, or in other words, you can say you can have a summary of that whole report, and then you can have question and answer based upon the given document. So that is also very much possible. Then you have chatbots, which is used to develop a conversation with the help of agents, and also a user can interact with that, and of course it can be very well customized. So it depends. So again, in order to have the customization, one needs to provide the specific data regarding to that company or organization, and what policy documents that organization or what policy document that organization or company follows. So all those data and things has to be provided. Then whenever that customized chat GPT or customized chatbot is going to operate, it is going to refer to that policy or that document before generating the response. And that's what we witness whenever we just go through this chatbot of, let's say, Amazon, Flipkart, or any other website or application. Then uh, we should know that how this generative AI works. So basically, there are three phases. The first one is training, where the Gen AI models are being trained with the help of massive amount of data, and that data can be text, image, code, video, etc. And with the help of this massive or vast amount of data, the patterns are being learned, and the relationship in between the data is being learned. And then the second part is the query part or the prompting part, how the prompting is being done and it is being processed. So when a user provides a prompt, for example, in the form of a text request, the model is going to the model uses its training to generate a novel and relevant output. So this is the important thing. So whenever, let's say, already the massive amount of data is there, and let's say you have asked to do certain tasks, then that particular model is going to take the help of the underlying massive amount of data, and it is going to give you or generate you a novel and relevant output. That is the important thing. It is not like that you ask a query that give me some flight details, which operates from India, let's say on a particular time, or you some certain timeline you have given, and it has given the flight details of US or any other country. So it is not going to there. And of course, whatever data you are going to get, you are going to get a process summary of it. So that's why it is being said that it is going to generate a novel and relevant output. Then some foundation models are going to be used, where the many Gen applications are going to build upon, and they are going to build upon large versatile foundation models that can be adapted for various tasks with minimal additional training. So as it has been discussed in the last slide as well, that the companies are working, or the people researchers are working to first create to build a foundation models, and then certain tweaks are being done on this foundation model. So all these ChatGPT 5, 3, 4, these versions are nothing but these foundation models only. Then if we talk about what are the benefits, challenges, and risk we have got along with the JI, with the evolution of JI. So first, let us talk about the benefits. So with this, of course, the productivity is going to get increased, right? The automotive or the tasks are going to be automated, right? Number of things are going to be there, for example, which we needs to do on daily basis, on multiple times. So all those things can be done. For example, we as a faculty need to write certain emails, and we also need to take care about that proper you know typo errors has to be avoided, grammatical mistakes has to be and proper solution has to be done. So all those things, because a number of time we need to write email, and let's say we need to evaluate the assignments on daily basis or on multiple occasions. So all those things can be done with the help of the generative AI. And when we do that, of course, we are going to have some extra time, and that time can be utilized to do the research. It is also going to help us in creativity and innovation. So it is going to provide the tool for sparking new ideas and creating novel contents. So of course, you just give the prompt with some innovative keywords, and then ask this model to generate, let's say, an image, or let's say a story. So it is going to do all those things as well. Then, of course, you can have your own customization, and which is very much applicable for certain applications and industry and use cases. So for that to have only very little extra training of the data is required. So once upon a time, I had to go to that AG office, that audit office of Chhattisgarh, and they were asking me to create their own customized application so that they can analyze all these bills, vouchers, and all. And um, if some vouchers are not as per the order or as per the rules, so they have got some the financial rule book. So the moment they are, because if they do it manually, then it is going to take a hell of time. So a customized version for them has been created, or rather has been just helped out for them. So I have just taken the policy document, and the few things or concerns they wanted to have. Of course, they wanted to address that biasness and all those things. So that has been done, and a customized version has been provided to them, and then they can use it if they require it. And then if we talk about the challenges and risks involved with this Gen AI, so one need to see how accurate things they are producing. So often they can end up having hallucinating. So hallucinating means whatever they expected to generate or give, they are not doing that. So that is what we mean by hallucinating. So as a human, as hallucinating is it's sort of lie, means we are not getting the actual picture. Okay, so at times it can also produce incorrect or false information. So that is why for academic purpose or for research purpose, where we want to have the exact and actual or factual data, then we may not rely 100% on these generative AI solutions. So we also need to look after the ethical and biasness. So the training data may contain biases that can be reflected in the output. Let's say you are just trying to create a policy, and on the web all the policies documents are from a specific country only. So whatever data or the results you will be getting, most of the time it is going to get the reference of those policy documents only. So it may be biased, right? The output which we are getting, it may be biased. Then misuse can also be there. So as we all are witnessing the number of fake videos or deepfake videos are being created, right? It can also create misinformation, because nowadays a lot of kids are directly making the use of Gen AI to get their treatment done and to get a number of things, and they believe that only that information is true, which may not, which might not be right. So it is also, and means a number of days I come across news where someone, just by having the advice of generative AI, have taken the medicine and then they end up getting into difficult situation. So the things like this are happening. And then apart from that, the more sophisticated cyber attacks are now possible. For example, using the generative AI, one can exploit all the vulnerabilities of an organization with minimal effort. Only a single person can exercise the vulnerabilities of multiple organizations at multiple places. Then, as has been the practice earlier, that we were able to recognize that these mails are phishing mails, right? But now, if let's say someone is creating a phishing mail with the help of generating AI, then the keywords which we use to identify that this is a phishing mail may not be there. So it is going to look so authentic that you won't be able to distinguish whether it is authentic, whether it is the faked one or the phishing one or not. For example, it is going to use all your personalized data. So all those personalization and basic details are going to be in that mail. So if these things are there with the attackers and all those things, then the things are going to get very difficult. Then copyright issues are also going to be there. That who is going to have the ownership of the content created by AI, right? So again, the policy documents are being drafted, and many more things are yet to come. So these are the challenges and risks associated with Gen AI. Now, to repeat it again, generative AI refers to the algorithms such as been adopted by ChatGPT, Stable Diffusion. It can create new content, for example, text, computer code, images, audio, and more. And when we talk about in the field of robotics, these things are going to go further. That means now, apart from creating these typical things, for example, text, computer code, images, audio, it can now generate actions and movements as well. Additionally, with the help of this Gen AI, now the synthetic data can be created, right? Which we were doing in the other applications as well. But now, specifically in the case of robotics, now we are just trying to see how Gen AI is playing its role in the field of robotics, right? So it can create large amount of synthetic data, and that synthetic data can be used to train, right? And so that when need arise, these robots can behave more accurately or more adaptively. Then it can write codes to control robotic hardware, and it is also going to enable reasoning about the physical world. So the basic elements of the AI model which we have seen initially. So now the moment it is having more information, massive amount of data it holds, then now it will be able to reason about its surrounding and it can adopt it more easily. So if we just try to understand the foundations of generative AI, so as we have seen that it is going to create the novel data or the output in the form of text, images, music, even physical designs, right? And they do it by learning from the complex patterns which are already there in the data, right? And what is the basic principle? The basic principle is that in this case, Gen AI models are going to synthesize new possibilities within the learned data distribution. And then they try to mimic the human creativity, the way we deal with the data, we deal with the things. Similarly, Gen AI also tend to do that because we have created them in such a way so that we get more familiarity, right? And if we talk about the history of the Gen AI development, then in 2014 onwards, suddenly the development in the generative AI has taken a lot of attention. So when this development in Gen has reported generative adversarial network, then thereafter people have just started realizing their importance. And then one more important development came in 2017 when the development of transformers models have been reported by Waswani. So that is also a very quite a landmark. So if you just try to see the evolution of robotic intelligence, then during 1962, 2000, some hard-coded things were being done where we used to program certain things very explicitly, right? Then the things were repetitive. In those things were structured, right? As we find in factories or industries and all. And then in 2010, the era of deep learning came for reinforcement learning, where the reward and penalty and all those things came into picture, right? But in 2020 onwards, a lot of things are being done in between 2010 to 2020, where the generative AI has paved its way. A number of foundation models have been introduced, and a lot of things are being done thereafter. And if we look forward for the future, so we are going to witness the embodied AGI in near future, where we are going to provide a physical shape with this generative AI capability. So that is what we are going to witness in near future. And of course, AGI means it is going to have number of functionalities, a number of capabilities, not a single one, the way we have got. Okay, so we will be able to walk, we will be able to have a good conversation, and we are going to perform number of activities. So all those things are going to get done. Now the point is why the people are talking a lot about it, or you can say why the convergence is being reported now, because the data scale or the scale of the data is huge nowadays. Why? Because this is the era of internet, and whatever data is available on the internet, all that data can be referred or can be used to learn, right? And that data can be in the form of text, images, videos, and all, right? So that has played a wide role to train the foundational model. Then there has been number of advances in the high performance computing, where number of GPUs, graphical processing units, and tensor processing units have come into picture, or a lot of development have been reported. So they are empowering faster computation. So with the help of these billions of parameters are being used to train the model and to perform the complex reasoning, right? And then the development of transformer architecture has also been reported. So these are some of the things which with which a lot of development in the field of generative AI is being done. And then we are also, of course, going to see how these generative AI developments are being used in further robotics. So certain applications and use cases are going to be seen. So before going further, let us see what are the main pillars of generative AI. So basically there are three pillars, and the first one in that one is the variational autoencoders, and the second one is generative adversarial networks. We call it as GAN. Then transformer-based language models. So this is a sort of we can say framework, and under this framework, certain other approaches are also there. For example, autoregressive and diffusion models. So that are there. So as discussed, that these are the basic three things. So in generative adversarial network, a generator and discriminator setup is being used to produce the realistic data by optimizing an adversarial game where each one is trying to fool the other. So at the same time, both the parties are being trained. So it has been a pivotal role in image synthesis and simulation applications. And when we talk about variational autoencoders, so they try to learn using the probabilistic latent representations of data, enabling continuous and interpretable generation of new samples. So whatever is the size of data, they just store their data without losing their context in a compressed form. So this is how the things in general being done in VAs. Then in diffusion and autoregressive, of course, these are the transformer models, and these are the different approaches. And in in the first approach, it is a sequential one where the things are being taken into consideration token by token, and in the other one, the things are being done from noise to data, where all the things are being taken, let's say, which are very sketchy initially, and then over the period of time, they are being refined. So, as discussed, VAs are designed to learn the underlying structure of data by compressing it into a smaller latent representation and then reconstruct it, right? Then how they do it? They do it with the help of probabilistic approaches to generate new data samples that are similar to, but remember, that are not identical to the original data. And there are two main components in VAE. The first one is encoder, where the input data is being compressed into a latent space representation. And in decoder, the reconstruction phase is being done. So the latent representation is being used to generate the data back. Okay. Now there are a variety of applications. To mention few: material design, fault simulation, manufacturing, production, data compression. So these are some of the applications of this type. Then there is generative adversarial network GANs. So in this case, two networks are being used. One is generator and other one is a discriminator. And they generally compete against each other to create highly realistic data. So whatever images are being generated or deepfake videos are being generated, all those things are being done with the help of these GANs only. Okay, so the generator initially produces synthetic data, while the discriminator evaluates whether the data is real or fake, forcing the generator to improve over time. So initially, let's say a random image has been generated, then it is being compared with the image with the real image. For example, this model is trying to generate a face of a human, right? A human face. Then it is going to compare with the real face. Then it is going to compare how close it is with the real face. So until it is get close enough, that refinement goes on. Okay. So this is what happens in this particular model. So the generator learns to produce synthetic output, and it can be in the form of images, sensor data from random noise. Then thereafter, the discriminator distinguishes it between the real data and the generator's output. And these two networks are trained together in an adversarial, or you can say the competitive manner or process, where one tries to fool the other. So it is the ultimate goal. And there are a number of applications. For example, synthetic defect creation. So then synthetic data in the form of images and videos, and it can be in a variety of applications. Okay. Then the third one is transformer-based language model. So in this case, again, what happens that transformers generally use self-attention mechanisms in this case. What is self-attention? For example, uh, a particular paragraph is there, and in that paragraph, each and every word is going to carry a particular meaning. So we, in this particular model, the weightage to each and every token is going to be provided, or you can say each and every keyword is going to be provided. So that's how this particular model works. Okay, so these models are pre-trained on the large text corpora and learning patterns and structure that represent the grammar, syntax, and semantics of a language. And once it is trained, the transform-based models can be fine-tuned for the other NLP task. So this is how it works. So I told you that this is a particular architecture, and there are two types. First one is autoregressive and the other one is division. And again, it is being used in variety of applications. And your chat GPT is the very famous application in that category. So what we are going to get with the help of generative AI in robotics. So when we talk about traditional robotics, it is going to use fixed set of algorithms, and sensor data is being used for repetitive tasks in controlled environments, right? But when we talk about Gen AI, then the robotics means the robotic Gen AI robotic employs generative models for dynamic adoption and handling novel objects or condition via learned policies. What does that mean? It means that in case the environment is changing, the environment is not static, or let's say the object which a robot is encountering, that is not a existing object, it is a new object, and the semantic to deal with that object is not being defined, right? Or it is very much possible that the policies how to deal with that object is not there. So how to go in that case? So the generative AI is going to help in that case. So if we talk about the key difference, then the Gen AI reduces reprogramming needs by 50 to 70% in a variable settings like warehouses. So it is very much possible that say you have coded a robot to pick items of certain dimension, right? But let's say then thereafter you told it to pick the item of some other color or some other texture or some other features, or let's say some other dimension. Then in order to do that, one needs to again reprogram the board, right? And it is going to take a lot of manual effort. So all those things can be effectively managed with the help of generative AI, where all the things are going to be analyzed by AI. Okay, the item is same and the dimension have been now reduced. So accordingly, this should be the set of instruction, right? So this is how it is going to help. So there can be variety of aspects, for example, environmental learning and output, and your Gen AI robotics is going to be useful whether the environment is unstructured or the continuous sort of learning is required, or you want to have the creative output. So Gen AI is going to give you the solution. Now, in continuation, what else or what other things it is going to provide you? So Gen AI is going to generate new contextually coherent outputs beyond seen example. So it is very much possible that whatever data set you have got or the output or let's say in the environment where a robot has been exposed, let's say the way we have sent a robot to that other planet, let's say, okay, moon, yeah. So the moment we have sent a boat to moon, so it can encounter very new challenges. So how to deal with these challenges, right? So Gen AI can give you a solution where those unseen examples or unseen problem scenarios are there. Okay. So based upon the amount of data it has got or the behavior which is there, then it can take the help of those things to deal with that current scenario. Then apart from that, it is also going to utilize self-supervised learning to uncover latent data structure. Then it is also going to produce multi-model adaptive outputs. So what we mean by multi-model, where the type of data is going to be different. And under variety of scenario, they are going to adopt accordingly. Okay. Then it is going to provide the capability to the machine where they can sense, they can think, they can act. That has been the obvious cycle, but now the capability is more. Okay. So if we talk about the basic components, basic core components of robots, it is going to have sensors, it is going to have a processor for cognition, then it is going to have some set of actuators to act upon, right? But now additional brain is going to be there. Additional capabilities in the form of Gen AI can be there with these boards. So with this, they are going to go beyond the automation. So it is because since the typical robots are lacking the generative adaptability, so with the help of this Gen AI, robots are going to have new designs and they will be able to create novel behaviors, whether the environment is dynamic or not. Okay. So of course we are going to take the dynamic environment into picture because that's where the challenge lies, and over there it is going to help you out. And then it is also going to create a human robot symbiosis. What does that mean? It means that it is going to allow robots to interpret human languages, emotions, and context. And with this, it is going to facilitate natural collaboration and task personalization. Because the moment we think of interacting with a robot, it must have to behave like us, right? It must have to converse, it must be able to have a conversation the way we have with other people. Only then we will be getting connected, right? So that's what we mean by human robot symbiosis. Then it is also going to accelerate the innovation because it is going to give you the novel data or the new outputs, and with the help of it you can also generate new layouts, control policies, and interaction models, right? So with this, it is going to give you the creative capability in physical intelligence as well. Yeah, sorry. Now it is also going to help in expanding the cognitive and creative scope of robots. For example, it is going to give you the adaptive perception. So with time, uh, it is very much possible that whatever data we have got in the form of images and videos, they are not proper data. Okay, some interpolation is required, some, let's say, some extrapolation is required, or let's say there is some missing data. So Gen AI may help you to generate that missing data, and with the help of it, it is going to improve the object recognition and the other capabilities for certain. And then since the motion planning is an inherent part of robotics, so it is also going to allow a robot to imagine many more trajectories which were not initially there. So that way it is going to optimize safety and it is also going to improve the efficiency. Then it is going to have language and behavior synthesis. So with this, it can generate context-aware dialogues and task behavior. And in automation industry, it can also generate various design, okay, and even the design optimization it can report. So with this, the cost effectivity and other design aspects can be introduced. And then apart from that, we can also have simulation to reality transfer, where it is going to be the gap between the virtual training and the real world deployment. Because we know whenever the things are being done in the simulation, that may not exactly replicate the real one. So how to improve that cycle? And it can only be improved when it is being trained in the variety of scenarios. Okay, so how to create those variety of scenarios? Of course, this is where we can make use of Gen AI. Then autonomous co-design, where the Gen AI capabilities can work along with the humans. Okay, so this is being called as autonomous co-design process. Then trajectory generation and reinforcement guided generation, zero shot motion transfer. Zero shot means a robot can generalize the control policy for unseen tasks or terrains or scenarios. So it is very much possible a robot may encounter to a situation for which it was not programmed for or it was not expecting, right? So how to deal with that? So of course, to have that, this Gen AI can help. Then natural language grounding, where it is going to enable robots to understand and execute verbal commands, because the moment we are moving towards the embodied AI, so we want our robot is going to be developed, which is going to have all the capabilities like us. So similarly, it is going to have the capabilities so that it can have a conversation or verbal communication the way we do with the other people. And then it will also going to have a contextual reasoning where it can interpret spatial, emotional, and other task context. So what is the context and what is the scenario in which the things are being done, right? For example, in some lightweight, okay, मैं तुम्हें मार दूंगा, right? I'll kill you, something in jokes and all. But one has to understand in what sense it is being said, right? So all those things can be provided to robots or in the field of robotics, you can say. Adaptive dialect systems. So with time, with scene, with scenarios, how a robot can maintain memory, personality, and adaptive responses so that the better interaction can be done. And you can witness these things very well that if you have done or if you carry out certain work in the chat GPTs and all, and if you are doing the conversation in the same chat window, then it will start giving you the response relative to the history, right? So this is what is being done by that model. So the same thing can be done when this particular capability is being visualized in the form of that embodied AI or embodied AGI. So generative learning for fine motor control in robotics is going to be there, where generative skill education, because skill is fine, okay, but with the help of this, new skills can be created. And how it is going to be done? By extrapolating from the prior skill set, okay, where some motion data and dexterity and autonomy is going to be there. So all those things can be utilized to create the new skill state. Then contact reach control through diffusion-based tactile modeling, and robot can predict and adapt to force interaction during the grasping and assembly task. So over here, because we as a human possess a lot of intelligence and capabilities, the way we deal with the objects, right? So the moment if we ask a robot to lift a bottle, so a lot of complexity is there. How to grip that bottle, how much force we have to apply, right, to lift it, and where to put it, how to leave it. So all those things are going to be can be provided with the help of GenAI. And of course, to do that, multimodality has to come into picture. And since that development has been done, so it can be very well used in it. Then the continuous task generation. So over here, generative policies allow robots to smoothly generalize to novel objects, shapes, and configurable without explicitly retraining. So with this, that rigidity is going to get avoided, because in between a number of instructions or final instructions or final movement can be provided with the help of Gen AI, so that the things can be handled in a smooth manner. So if we just try to compare traditional versus general AI, on adaptability, task novelty, and efficiency metric, then we can find that then Gen AI, it is going to have a gain of more than 70% in dynamic environment, right? And we are going to have the task novelty of 80%, and also it is going to give you more efficiency. So to be specific, it is going to give you more than 30% of throughput. And if we just try to go by the metrics of success, then for grasp success, it is going to have 80 to 90% on novel objects. So any objects which for which the robots were not trained for. So if the robot has got the Gen AI capability, then more or less it is going to get the knowledge from the web or from all the sources, right? From where that fundamental models have been developed. And by having that, it can deal with that object. And then it is going to have that design speed 100 times faster than the normal one. While if we talk about if we talk about the adoption time, then for manually adoption, it is going to take days of time, right? While in Gen AI, it can be done within seconds. So these are some of the advantages of having Gen AI with these metrics. So as we discussed, that embodied AI means where the brain meets body, right? So just imagine a humanoid robot is there, okay? And now that humanoid robot has got this chat GPT sort of capability. So it is going to give you all the answers. And if in case if you come across the paid version of GPT, then it has got voice mode. So you will feel so interactive with that one that whatever question you ask, it is going to give you the answer for that one, right? So the same capability, because it is already there in your mobile phones. So when a robot is there, when a robot is there in shape, then it is going to behave like a human only. Okay. Then how it is going to do that? It is going to do that with the help of VLA model. And what is that VLA model? VLA model is vision, language, action. So it is a multi-modality concept where the data is being first taken with the help of vision capabilities. Then whatever instruction is being said or is being told, those instructions said are going to get break, they are going to be get analyzed, and then accordingly the actions are going to be taken. For example, if we just ask a robot to pick a blue cup from the top of the shelf, right? So how exactly a robot is going to do that? And imagine a robot was not trained for it. Okay. So what it is going to do first with its vision capability, first it is going to identify where exactly is the cup. Already some features have been described that it is a cup, it is a blue color cup, right? So it is going to locate that one, and moment it has been located, what is the orientation, all those things, and then what instruction has been said. Instruction is that you need to go locate and pick it and put it a particular place. So all those instructions are going to go down, and then they are going to get executed using action model. So this is what is being done. And then when we talk about advanced perception and reasoning, of course, all those data is going to be used to understand the semantic, right? And then all the related properties are going to get analyzed, and then those things can be used to deal with the environment or with the object, right? So it is going to go beyond the object detection, where apart from detection you can deal with it, right? Then semantic navigation, because in earlier times we used to say, okay, just let's say you need to provide the exact coordinate to uh, go to that particular location. Now over here with the help of this Gen AI capabilities, semantics can be generated, and then you can say, okay, in my room, go to the kitchen and give me a glass of water, right? So it is already going to create a map, and it is going to locate where exactly is the kitchen, where exactly is the glass, and then it is going to identify the landmarks and all, and then it is going to create a proper route for that. Okay, so this is how things is going to be there in semantic navigation, where rather than giving a exact coordinate, you are going to give the instruction to a robot in a general language. Okay, then it is going to provide you the capability to handling the unknown, right? What shape and affordable detection and zero shot means, for which the robot was not trained how to deal with those objects or such objects. Then it is also going to help you in creating a variety of robotic code, a bit you can say a detailed code. For example, we have just seen a robot operating system and webbots and all. So it is very much possible that whatever control programs are there, and you want to write the programs for that. So you have created the model, and then you want to create a basic structure to control that board. So that you can do very well with this Gen AI capabilities. Then data scarcity. So again, a synthetic data can be used, and with the help of that synthetic data, what can happen? You can simulate variety of scenarios that what is going to be done when this particular scenario happens. For example, let's consider an example of a warehouse. So what happen if some items fall down? So in that case, how the robots are going to navigate, right? Let's say if some unwanted event happen, then what to do in that case? So all those cases can be simulated, and then the robots can be trained accordingly. Okay, so this is called as generative simulation. Then how the robots are going to have the capability where they can have the natural conversation with the human beings, and also all those capabilities also can be provided. And then Google DeepMind RT2 is there, which is making the use of that VLA model, which we have just discussed. And then another example, okay, studies PAL E, where a number of things are being developed. And over here, it has been trained over 562 billion parameters, and diffusion models is being used. And this is example of that only. Let me play a video. So over here, the use of generative AI is done to create a set of sequences or actions rather. And remember, this particular robot was not trained for this. So all these things are being done with the help of this generative AI. And these are adversarial disturbances which are being created. Right? Now, some developments such as Tesla, where end-to-end control is being also provided, where it can sort number of objects and it can do number of things. For example, yoga and stability test and all those things. So it is also there which adopts the Gen AI capabilities. Then the power of simulation, where you can even generate the whole scenarios, and then you can observe how the things are being done in that scenario. For example, you can just say that, okay, a messy kitchen is there. Okay, now you just need to correct it. Up now, there can be a variety of possibilities of having a messy kitchen, variety of possibilities, right? So maybe in one case only the glasses are there on the floor. In other case, along with glasses, the vegetables are also there on floor. A lot of dust is there. So a huge amount of possibilities, a variety of possibilities are there, right? So each of the each possibilities or variety of possibilities can be generated, and then you can see whether your robot is able to clean that messy kitchen or not, right? So you, let's say you have provided the capability, now you just wanted to test it. So it is not possible to create each and every type of scenario of messy kitchen. So this is where these things can be done. So NVIDIA Isaac Theme is one such toolkit where one can do that. Then what is its impact on manufacturing 4.0? So of course, rapid retooling, quality control, and cobots can be there, which we already discussed, right? Then it is also going to impact logistic and warehousing the way we already discussed, right? So it is going to handle this unique items, stock keeping units and all. Then with the help of the generative AI, the routes can be optimized and variety of items can be handled effectively on runtime specifically, right? And with the help of it, of course, autonomous boards can be coordinated effectively or efficiently. Then it is also going to mark its impact on healthcare. So it is going to help in surgical activities, care robots, and lab automations, right? For example, if you just talk about the surgical aspect, then it is going to give you, okay, given this scenario, how much force a doctor should apply, or let's say a robot is there, then it is going to identify the that area, that how much blood is coming or what is the texture of the skin, okay, and or there are so many delicacies and all. So all those things can be done and can be analyzed with the vast amount of data from which a model has been trained, and then the action can be taken accordingly, and the people are doing it, right? Then they can act as a home butler, where the moment they encountered with some unknown things and all, then they can use that Gen AI capabilities to deal with that. Now, of course, there are certain challenges. For example, how we are going to deal with the latencies, because it is going to take some time. Let's say if you have given some query or some prompt, which is a deep one, not a simple one. Okay, so it takes some time. So how to deal with that? Then at times it may produce some wrong results, right? So how to deal with that? Then of course it is going to consume a lot of power, and how to have that much of power, it is also one of the challenge, because the robots are given to you only limited battery on board. So how to do that? Then the safety and verification concerns are there. Okay, so we must have to have guardrails and explainability. If certain things are being done, then why it is being done, they must have to state the reason. Apart from that, if certain things are being overridden, means if certain wrong things are being done, then that AI capability must have to be overridden to have the to make the thing safe, right? Then simulation to real gap is also there. It seems good, but our simulation is never going to be perfect, right? So it's always a continuous process, and how effectively it can be done, it's also one of the challenge. For example, domain animation, how what is going to be texture, mask, and lighting. So there can be variety of ways of lightnings and all those things. So how the things are being trained or being done for that. Then what are the ethical consideration? Because as machine becomes more competent, we must have to ensure that their goal remains aligned with ours. Otherwise, the things are going to get worse. So apart from that, we also have to look about the job displacement and bias in action, how we are going to deal with the bias and all, right? That is also one of the challenge. Then rise of humanoids are also going to be there, right? So this is not a challenge, but this is what we are going to witness in future. Then cloud robotics, we have already seen that how the cloud robotics is paying its way. There are a number of things for which a robot was not initially designed for, and how those capabilities and functionalities can be provided to the robot on the run. Path to AGI that we have briefly discussed, that the next step towards the robotics when it embed the Gen AI capabilities is the AGI, where they are going to do each and everything the way we do. Okay. So they are going to provide a paradigm shift, and the VLA models are going to play a vital role, and they are going to give you the generations, and they can of course handle the zero shot scenarios, and they are going to have their impact in the variety of applications, for example, manufacturing, logistics, automation, etc. And there are number of challenges which remain, which will be there, for example, safety, latency, reliability, and other things. So this is it, and then we are going to see how the things shape up in the form of embodied AGI. These are some of the references for, especially for images which I have taken, and this is it from my side. I'll be happy to answer if some queries are there. Participants, are you there?
Yes, sir.
Yes, sir.
Sir, thank you for the good video, sir. It was very clear. Okay, what was it? Sir, I'm currently working on biomimetics robotics, sir.
Okay.
So, I mean, I want to know what would be the future of the robotics from now? Okay, you have shown some videos, and you have shown how they are used in hotels and stationery shops and all. But how do you see the future, sir? Because robots have come in all the fields. So, I mean, will all of us able to accommodate robots and make them as our colleagues, or will they take over us? I mean, what is it? Which way it is?
The way I see it, because see, it's always in Hindi we say विज्ञान जो है वो अभिशाप है या जो है वरदान है. So I just forgot. So see, now with the development of Gen AI and robotics, the combination is going to be very deadly one. And since the human greed is not controlled, if the human greed is not controlled, then it is going to overtake for sure. So
Okay.
we have to do the things or do the developments in a controlled way. It has to be ethical. It has to be explainable.
Correct, sir.
Responsible. Only then the things can be converged in a good direction.
Yes, sir, that is one. But as I see, because the robots they have come even in what you call medical field. Okay, basically they are already doing surgeries in some of the countries. So even maybe they may come into teaching also in the future. We don't know. Okay, so they may keep on coming. So how do you control? I mean, one aspect is we have to upgrade ourselves. That is one aspect. Second aspect is how to come over this challenge, this continuous challenge. There is a continuous war between humans and robots in terms of knowledge or in terms of upgradation.
And you will be amazed to know that I always have a fight for this particular topic with my kid. I always say that human greed is going to overtake, because now it is very much clear and very much evident that we have started losing job with the involvement of AI and all. Yes, means the things are there that new jobs are going to get created, but it is going to get some time and the people needs to train themselves, and that is going to take some time. So how do you feel that there? That is the challenge. That is the challenge, because it has been very evident from the past, because new technology will phase out and new one means the old technology will phase out and new will come in. So it's up to the people how cleverly and how responsibly they take it. If they won't, then it is going to be very difficult. So that's where I told you that human greed, human greed.
Anyway, thank you for the wonderful presentation, sir. I really enjoyed the session. Actually, during this time, to be honest, I sleep. But your session was really interesting. So I thank you once again for that wonderful session. Hope to collaborate with you in the future, sir. Thank you very much.
Thank you for coming. Any other question?
Dear faculty members, any queries?
Hello, sir.
Yeah.
Yeah, thank you very much for your wonderful session, sir. I thoroughly enjoyed very much, and you opened many doors to us to think in different directions. I have one question related to the generative AI for robotics point of view, sir. So in robotics, sensor play very important role. Okay, so how generative AI will help to sensor or to the robots to perform or accomplish a specified, for example, a precision related task? Will it be take care of that too, or it has some restriction for that?
See, let's say if we just take an example, if you just want to pick a bottle, then it requires precision. The moment you apply less force or more force, then that particular object may not be in the original shape, right? So
Yes, sir.
what can be there with the generative AI? All those possibilities are going to get explored. Uh, I don't know whether that movie is there, uh, where I just okay. Anyway, so all those possibilities are going to get exploited or exercised, and then when all those things exercise, then that knowledge is going to get used to deal with that one. So with that, what will happen? The more precision one is going to have, more accurate idea, and that idea can be in the terms of precision as well. For example, you may apply some amount of force, but let's say that is not the optimal one. And how do you know that? So you are going to know it when you experience that scenario, only then. And how you are going to experience when you try each and every one, only then.
Yeah,
right?
correct. So, you mean to say the environment specific we have to
Yes.
be
So
work, right?
what Gen AI is going to do, it is going to create those new, you can say, novel ideas or novel, you can say, outputs to deal with that, or set of instructions to deal with that, which was not there initially in that book, textbook. Okay, let's
Correct,
say
sir.
only 10 were there, and you have exercised only 10, and you have found out that out of those 10, only this one is the best one. But you do not know that even beyond those 10, there were many other opportunities as well. Right? For example, if you are just going from one place to another place in your city, and you only know 10 ways to go there, so you will only be thinking that out of those 10 ways, this is the optimal one. But with Gen AI, it is very much possible that you come to know about 10 more such paths. So that is the advantage.
Yes, okay, sir. And the scenario you explained currently, that is a support system to the human, right? Yeah, okay. And it is not directly attached or directly interact with the humans. Okay. And if I move to the medical application, for example, the surgery kind of the applications, or diagnosis related applications, or disease prevention and corrective applications, their generative AI, would you think that it will work accurately?
See, if you just follow my presentation, then at the last, I have told some limitations as well. So all these are ongoing process. It is not
Yes.
like they have fully matured. Okay,
Yes,
so
yes,
that is
correct.
why that co-assistance is always required. It is going to be daily
Definitely.
open surgery.
Yeah, definitely, sir. Without that, we can't. Okay. Yeah, thank you very much, sir. Okay, actually, my area is underwater robotics, sir, and I'm looking forward to apply AI in that applications perspective. So I was a little bit very conscious and serious about how I can deploy AI related knowledge to that applications. So thank you very much.
Maybe in that underwater scenario, you can simulate all the underwater parameters or constraints and all, and you can see how your system is behaving in that one.
Yes. Okay. Okay, thank you very much, sir.
Any other query?
Any queries? Dear faculty members, any queries? So we sincerely thank Dr. Rajesh Doria for graciously joining us today and sharing his valuable expertise. Your insightful session and extensive knowledge in advanced computing have truly inspired us all. We are all deeply grateful for your time and significant contribution to making this faculty development program so impactful. We also extended our heartfelt thanks to all the faculty members for their active participation and engagement throughout the session. Your enthusiasm and dedication are greatly appreciated. So with that, we conclude today's session. Thank you once again, and we look forward to meeting you in the next tomorrow session. Thank you. Thank you so much, sir.
Thank you, madam, and
Thank you, sir.
especially I would like to extend my thanks to Kanya Kumari, madam, for having me in this FDP. It was really enjoyable for me. Thank you.
Thank you, sir.
Can I leave, ma'am, now?
Yes, sir.
Thank you.
Good night, all.